Hello, class. Welcome to Researcher TV, where learning research is made easy. Today, we'll be learning about quantitative data collection and analysis in research. We're going to explore some fascinating tools and methods that make quantitative research so powerful and precise. Likewise, we'll have an introductory discussion on quantitative data analysis, and I promise to keep things clear, simple, and of course, relevant to what you need to know for your future research projects. So let's jump right in. Let's begin with knowing what quantitative data is. What is it? Basically, this is the type of data that we can measure and express in numbers. Okay, so this is measurable and can be expressed in numbers. All right. Now, imagine you're studying and how many students prefer online classes over in-person ones. Quantitative data lets us use actual numbers to represent preferences, opinions, or even things like test scores or time spent studying. It's a bit like turning real world experiences into numbers we can analyze, and it's pretty cool, right? But if we will be very technical about quantitative data and in terms of scales or types of variables, this is only true for continuous variables or scales. And these continuous variables or scales include, of course, our interval scale or interval variable and ordinal variable. So which both have meaningful numerical values and consistent with intervals, allowing for mathematical calculations and statistical analysis. However, if a variable can be categorized and numbered accordingly, then it can be quantified during analysis. Now, always remember that quantitative data allows the researcher to process and analyze it in terms of mathematical, calculations, or in terms of statistical analysis. All right. So it's always they come together. They always come together: quantitative data, mathematical calculation, and statistical analysis. Right. Now, let's take a look at the first part of our lecture discussion, and that is learning about quantitative data collection. Remember that this part of your research is crucial because your evidence will be based on how you gather your data. So prior to your data collection, you need to remember, or you need to be particular with the following considerations. So number one, you need to have a clear research question. A clear research question will guide, and this will now align us to our goal. Okay. And if we have an alignment with the goal and our research question is clear, then we can be confident that our data is accurate and precise. And of course, one major consideration that we have to remember is to ensure that our method and instrument are valid and reliable. So how do we really gather this data? In quantitative data collection, it's all about getting information in ways that are systematic and applicable. Yes. So we need to remember that it's also systematic and replicable. Remember these two words because these will now play an important role later on. And this means that if another researcher repeated our study, they'd get same or very similar results. Okay. Now, there are two components of your data collection. We have your method and we have your instrument. So what is really the difference between the two? When we say method, we're talking about approaches, strategies, and processes. So these are intangible components of your data collection. While if we're talking about instruments, or instrument, we are referring to the tool, device, or specific measurement tool, okay, where the our data will be gathered. Okay, so method and instrument should always go hand in hand, or should always complement each other. Okay, now let's move on to the types of data collection methods and their specific instruments. So we will begin with the very basic one. This is the one that's actually it's widely used. So we have your surveys. All right. Now for surveys, one of the most common tool or instrument that is used for a survey method of data collection is, of course, our questionnaires. All right. Now, surveys are super popular in research because they let us gather any kind of information. Okay. Let's gather any kind of information um, that is from a lot of people so quickly and very convenient. Hence, surveys are considered to be versatile, flexible, and an efficient method, okay, of data gathering. Efficient because you would have easy administration. So giving your printed questionnaires or probably just sharing online links for your online surveys will be easy peasy. So it's not going to be that hard, or it's not going to be a like a chore. Okay. And as what I've just mentioned, there are several ways of how surveys or how survey questionnaires can be conducted or administered. Okay, so it's very convenient for our respondents. And usually, survey questionnaires have what we call your close-ended questions. Right? Now, these close-ended questions are also known as like forced choice because you have choices, or your answer will only depend on the options that are being presented to you in the tool or in the questionnaire. And meaning respondents get to pick these set of answers like yes or no or multiple choice. And this way we can easily compare and analyze answers. And because of this nature of our survey questionnaires, this tool is very applicable. And surveys gives us a ton of information in an organized format. Yes. So what's good about your surveys or your survey questionnaire, survey method is that it's very organized, making them perfect or fit for your quantitative studies. All right. Now let's proceed to the second. We have our observation. For this, our instrument actually either your observation forms, right, or your checklists. Yes. So we know for a fact that if we talk about observation, okay, we collect data by watching people, events, or situations in real time. Now, it's usually dependent on our visual and auditory inputs. Okay. However, observation is not just only appealing to our senses. It also has something to do with other cues or other relevant sources of your data, like for example, the dynamics of the people that you observe, or how things are once you are immersed on your subject. So there are actually different kinds of or types of your observation. So firstly, we have your participant and non-participant observation. So in your participant observation, the observer becomes part of the subject. And of course, your non-participant, you are just plainly an observer, like an external researcher outside your subject. Okay. Then let's not forget that there is also your direct observation and your indirect observation, right? So direct observation has something to do with time and place. So the observer is within the time and the place of the observation. And then indirect, like a recording or a the subject or the event that the researcher will observe is already done or has already is already finished in the past. Yeah. Now, in doing your observations, you could note down things like number of times each student contributes or how they react to different situations. And observations are really very valuable, but we have to be careful. They need to be as objective as possible because the tendency of observation is that you might be subjective with your observation. Your observations are influenced by your own perception, beliefs, value system, knowledge, orientation, and so many other things. So sometimes researchers use checklists to help them standardize what they're watching for and making it easier to analyze later. So that's the purpose of your checklist because your checklist actually makes your observation more objective. Okay, now we have your tests. Yes. So your test, of course, is a method. And the instrument here are also tests. So it's like test is both a method and an instrument because um, it can interchangeably be used or this particular method is also a tool in itself. Okay. Now, tests are used when you want to measure specific skills. So the good thing about what's interesting about tests is that it is really very, very specific. So it's specific, or in short, it is tailored, right? So tailored in terms of the nature of our variable or parameter. So for instance, I want to measure knowledge. So you're going to give the participants your test, and the test is valid or specific only to the knowledge or the construct that you wanted to measure. So think of standardized tests you've taken. These are structured and scored in a uniform way, which makes the results reliable across different groups. And tests are often used in fields in psychology or education to assess things like problem solving skills or reading comprehension levels, or any parameter that's not really tangible or not easily observed. So we have to take note that tests are not the same. There are several or different types of tests, but actually there's only two. So first we have your standardized test. So your standardized test is, as what I've mentioned a while ago, is scored uniformly. So there is a uniform scoring, okay? Uniform scoring. This one is actually more stable, universal, of course. And at the same time, it is valid and reliable. So it has a high validity and reliability because it's already a standardized test. So examples of these include your achievement tests, university tests, entrance exam, personality tests, and the like. All right. Okay. All right. So the other type of test is, of course, our non-standardized test. Right. Our non-standardized tests are usually known or commonly known as your researcher-made tests, but these are tests that are administered in a certain set of people and is only limited for context or population. So here, the scoring is arbitrary. So meaning depending on the proponent or the researchers, how they establish the scoring system for the test. And actually it has sorry, not low validity, but it actually has low reliability, but it's a valid test. No, it's valid because it's contextualized or tailored specific to the construct or the goal, However, it has low reliability because it's not as frequently used, or it has not been utilized many, many times as compared for our standard access, and that it's not really universal. Okay. All right. Now let's move on to experiments. Experiments are these type of data collection method is very specific only for scientific research like randomized clinical trials or yeah, experimental researches. So remember that the main, okay, the main element of your experiment is of course the presence of your treatment variable. Now, this treatment variable is also known as your intervention. All right. So because we are trying to test the effect of the intervention, your experiment actually explores on the cause and effect, particularly on your independent variable and your dependent variable. So um, we measure our experiment, or experiments are also measured through tests, but unlike the written test or the standard pen and paper tests, experiments would have various types of tests, and these tests are done according to the nature of the parameter. Also remember that in order for an experiment to be uh legit, okay, or valid, you need to establish two groups. We have your control group, okay, and your treatment group. So we all know, and we have learned this before, that control group, no intervention or no treatment variable, while your treatment variable receives the intervention. And remember, okay, because you wanted to establish a valid results, or we need this one should be very precise and very accurate, there should be high control. High control meaning that we control our variables. We try to make our variables uninfluenced by other variable or other external influencers or factors, so that we could get, or we could arrive with our desired and ideal results. Okay. All right. So remember that we control certain factors and we see how they affect an outcome. So that's what we do in experiments. Okay. Then another one is, of course, our interview. But you may say, you may probably be wondering, sir, why do we have interview when interview is actually a qualitative method? Well, not exclusively. We can still do interview, even though it's even though it's we are gathering quantitative data, right? Okay. So in interview, our tool or our instrument here are, of course, your interview guide or your schedule. Now, your interview schedule is actually more structured. You really cannot, get away or deviate from your question reference. But an interview guide is more flexible. So you could modify your question, you could ask additional questions and something like that. So depending also on the type of interview that you're going to conduct. Okay. Now they're usually thought of as qualitative, as what I said, but they can also provide quantitative data if we structure them with fixed numerical responses. So for example, if you would say, on a scale from 1 to 5, how confident are you about your online learning? You're turning opinions into numbers you can analyze, and interviews are great for getting um, you know, uh, follow-up questions, and you can explore now with the current data that you are gathering as well. Okay. Now, we mentioned that there are also different types of interviews. Okay, so first we have your structured. The type of interview really depends on how you ask your question. So we have your structured interview, or we use your structured questionnaires. Okay. And these structured questionnaires use closed ended question. Okay. So for example, you would say, did you eat lunch today? So you either answer yes or no. So that's a structured questioning, close-ended question or multiple choice question. Then we have your unstructured questionnaire, okay, wherein you get to have an open-ended questions. Yes. So the research participants would freely answer and put his thoughts into it. The thing about your unstructured questionnaire is that it's kind of hard or difficult to process because of the diversity of responses. And that what makes structured questionnaire more advantageous because in terms of tabulation and tallying, it's pretty easier or a lot easier than unstructured questionnaires. And finally, of course, we have your semi-structured. So your semi-structured questionnaires, okay, is a combination of both your close-ended questions and your open-ended questions, okay? So don't forget these types of questionnaires, okay, when we do our interviews. Okay. Now, since we actually mentioned that interviews are very qualitative, here is a comparative view of the types of interview in quantitative and qualitative data. So for quantitative, we usually opt for close-ended questions and we have a rating scale or rubric. So instead of the participants, checking or giving their answers on a pen or paper or clicking on the link, they give their answer verbally through the interview method. So responses are numerical and the large. And here, remember that when we do quantitative interviews, our sample size is usually large as compared to your qualitative interviews. Okay, so structured type is used to minimize interviewer effect, which means that the responses of the participants may be affected by the behavior displayed by the researcher on the manner that the questions are presented. So the qualitative interviews are actually the complete opposite of your quantitative because instead of using closed-ended questions, you do open-ended questions, no rating scales, responses are non-numerical, there's no limit. The participants or the interviewee could just freely give their response, okay? But sample size is small, usually just a few. Because in qualitative interview, we process this through thematic analysis. So in order for us to do that, we transcribe the interview and then we do some coding, and it's kind of like a long process compared to your quantitative interviews. Okay. All right. Next. Okay. Ethical considerations. So you may wonder, sir, do we really need to be ethical when gathering data? Well, obviously the answer is yes. Why? Because ethics is super important in any research involving people, particularly since we are doing social research or psychological or educational research. Mostly our participants or respondents are um, human respondents. So ethical considerations mean respecting our participants. So this includes getting informed consent, which means that people understand what they study about and ensure privacy and the like. So here are the important, okay? I want you to take note of these important or crucial considerations in ensuring that your data collection and your entire research process is ethical. Okay. Oh, sorry. Oh, all right. So let's begin with, of course, okay, the procurement of our informed consent. So this is the basic ethical consideration. Why? Because your informed consent will signify that the participants voluntarily participate in the data gathering. So there's no coercion. They freely and without any inhibition took part in the data collection. Of course, we also need to consider confidentiality. Okay. Confidentiality is protecting participant identity and personal information. Okay, so we do not um, identify who are our participants, so we don't ask for their names or for any personal information. And it goes hand in hand with anonymity. Okay. Now, the thing about anonymity is kind of different because here we ensure that data cannot be traced back to the individuals. So if in confidentiality we don't know who participated, in anonymity we do not link the responses to the person. Well, for example, I'm the researcher, I know the proponents because I'm the one who gathered their data, but I'm not going to link the answer to its source because it should be anonymous. So you do not know whose answer was that. Okay, so just maintaining the barriers between the data and to its source or to the individuals. Next, we also have your privacy. So in privacy, we know that respects of personal boundaries and sensitive information, proximity, and not disclosing. So privacy is more like encompassing your anonymity and confidentiality considerations. Also, this is also interesting. We have your non-maleficence. Your non-maleficence is avoiding harm or discomfort to participants. So primarily, you are blocking your participants from any threats, hurt, or any form of violence. And because of technology, you know, integrity of your report can be put at stake. So another important consideration is data integrity. So what do we do with data integrity? We actually collect and report data accurately and honestly. So let's say during data collection, you were not able to get your desired results. So what you did, you tried to alter the findings. So that is not ethical. Okay. Likewise, also plagiarism, not recognizing the author or the source of the author or the source. So that's under your data integrity. Remember also that participants can withdraw anytime. So right to withdraw, but remember, they should understand the consequences or the repercussions if they're going to withdraw from the research study or from the data gathering or collection. And finally, of course, researchers need to be transparent. So transparency, you clearly explain the study purpose, methods, and usage of data, and you do not conceal any part of the data gathering that, you know, if known by your participants, might change their decision to participate because it might compromise their private information or it's kind of like dangerous for them. Okay. Yeah. All right. Now, so all of those things are already done. You are already very ethical in terms of your data gathering. You already know what method, what instrument to use. You're sure that it's precise and accurate. And you already have the data with you because you have already completed the process of collecting your data. So now we will proceed with data processing. So once we've collected our data, it's time for processing. And this is where we organize, prepare the data for analysis. So basically, class, data processing is like a pre-analysis activity. Okay. I don't know why I wrote it here on the side. But anyways, yeah, it's a pre analysis activity. And what we usually do, we have three like mini or three activities. Okay, or steps. Okay, so first we have to edit, code, and tabulate. So when we edit, what we do is we check for what? Okay, of course, I not cheat. I'm sorry. It's not cheat, but rather we check for errors or inconsistencies. Okay, inconsistencies. We also call this one you're editing as your data cleaning. So any instrument or any questionnaire for that matter that is incomplete or sorry, it doesn't have the uh like it was tampered or incomplete, tampered, or missing, it has to be removed from the pool of our data. Okay. Now, coding, on the other hand, is where you assign numbers to responses. So remember that when we do your data collection, not all the data that you'll be gathering are numbers or numerical in nature. For example, if you're going to ask for demographic variables, so you have to count how many males, how many females. So you assign a numerical code so that it'll be easier for softwares to process these data. Okay. And especially if your data are originally in words. Now, and finally, we do your tabulation. So what do we do in your tabulating? You arrange data, okay? You arrange the data in tables so that you can spot patterns. Okay. Tables to spot patterns. Well, in a way, your tabulation is more like seeing your data summarized, but in its raw form. You know what I mean? Like you would know, okay, I can see lots of ones, lots of fives, there are lots of zeros. So before processing, you already have like a feel or an overview of what the data or the results will be because you have tabulated them and then you lay them down on tables. And this will now processing data correctly is essential to ensure accurate results in your research. Okay, yes, we are done with the data processing pre-analysis. Now we will begin or we will move on to the proper data analysis. So data analysis can seem daunting, but it's just about making sense of numbers. Well, me personally, I'm not a fan of mathematics, but if the numbers or math is in research, that's very interesting for me. And because data analysis and research is a process in which gathered information are summarized in order or in such a manner that it will yield answers to the research question. So in data analysis, you have here your data, and then you make a summary of your data, and then you answer your question. So basically, that's what you're going to do. Because once you have analyzed your data, you are now going to go back to your statement of the problem and then answer that using that summarized evidence. Okay, so quite interesting. So during quantitative data analysis, gathered information are breakdown and ordered into categories in order, okay, because as what you've said, there's a summary here, okay, it leads us into, okay, the creation of trends or patterns. Yes. So there are trends or patterns here. Oh, sorry. The trends or patterns here. Let's make it a little bigger. So we have your trends or patterns. So that's what you do when you summarize your data. So there are trends or patterns in a certain condition. Okay. So in quantitative research, the numerical data collected is not taken as a whole. In order to understand it better, it is analyzed into components based on the chosen research variables and research questions you're going to answer. So hence, given that your data analysis in quantitative is deductive. Yes, right. It's deductive because what do? Okay, you're breaking it down into parts. You try to see trends and patterns from your summarized data. Okay, so these numerical data are usually subject to statistical treatment, and depending on the nature of data and the type of research problem presented. So as what we have mentioned at the beginning of the class, your data analysis in quantitative, it's always statistics. Okay. So there are actually two types of statistics. Okay, let's not really complicate this one. We just have to learn the basics of quantitative data analysis. So we have first your descriptive statistics. So what do you do in your descriptive stat? Okay. So in your descriptive statistics, it basically just summarizes, no? It gives it's a process of getting the bird's eye view. Yes, the bird's eye view of the data, but it's kind of like superficial in a way. Okay, so here we do your measures of central tendency, your frequency counts, your percentage, variability, standard deviation, and the like. Okay, so yeah, bird's eye view or a snapshot of our data, but it's really superficial. It's just on the upper level or just on the top level, surface level, I mean. While when we do inferential statistics, okay, activities here would include making predictions, okay? Yeah, we're making predictions in inferential statistics. We also test hypotheses and we analyze relationships. Don't forget, also comparing. Okay, so that's what we do in inferential statistics. So for example, if you want to know whether there's a link between study hours and test scores, inferential stats can help us find it out. And these methods let us take insights from our sample and apply them for a larger population. Okay, okay, there you go. Now, so we already know that your data analysis in quantitative is usually processed through statistical analysis, and it could be descriptive or inferential in nature. But there are also, okay, we also process your data based on or according to the number, okay, of variables we're looking at. So we can analyze data in different ways, and this one is based on the number of variables we're looking into, okay? So there are actually three: univariate, bivariate, and multivariate analysis. So univariate analysis means studying only one variable at a time. Yeah, we know that. So one variable at a time, like average score, no? So only just one variable. Bivariate, of course, two, and multivariate will be like three or more. Yeah. Okay. So bivariate analysis compares two variables like test scores and study time to see if there's a relationship, while multivariate analysis looks at multiple variables at once, which helps in complex studies, such as how study time, sleep, and diet together impact test performance, and each type of analysis gives us different level of insight. So let's try to identify some of the tests, okay, that belongs to the type of data analysis according to the number of variables. So for univariate, it is where our descriptive, oh, sorry. Okay. It's where we can see our descriptive statistics. All right. So we will learn later about the mean, the median, okay, and the mode. Okay. Of course, we also have here your standard deviation, all right, variance for that matter. And however, your univariate is not only exclusive for descriptive stat. We can have a one sample t-test, okay, as a univariate analysis. For bivariate, okay, let's try to move this one. I think we don't have enough space. Okay. Oh, sorry. Oh, there. All right. Oh, okay. So for our bivariate analysis class, okay, examples here, usually we measure relationships. Yes. So associations or relationships of your variables between only two variables. And these include, okay, a very particular or familiar test is, of course, your Pearson R, Pearson correlation coefficient. Yes. Or your Pearson moment correlation. Right. Go. Oh, go E. No, wrong spelling. Oh, there. Pearson moment correlation. It measures the strength and direction of the linear relationship between two continuous variables. And of course, let's not forget, we also have our chi-square test of independence. Yes. So we have your chi-square test of independence. So what do we test here? We test the association between two categorical variables to see if they are independent of each other. So the difference is your correlation, all right, measures continuous, okay, variables, while your chi-square test for independence, categorical, okay, or your discrete type of variables. Multivariate, on the other hand, examines more than two variables to understand complex relationships. And usually, what we do here, or the analysis tests that are considered to be multivariate, include multiple regression. So this one is like a correlation in steroids, because you examine the relationship between one dependent variable and two or more independent variables to predict outcomes. So it's like correlation, but three or more variables. And then we also have your factor analysis. What do we do in your factor analysis? Identifies underlying factors or constructs that explain the patterns of correlation among multiple variables. Yes. So there you have it, guys, or there you have it, class. Data analysis according to the number of your variables. Now, we've mentioned that descriptive statistics is one of our statistical analysis, and this is actually like a basic, or not really a basic, but a fundamental statistics, because we cannot proceed with inferential statistics if we do not first complete your descriptive stat. Okay, so let's look closer at descriptive statistics and where we break it down into meaningful parts. We've got frequency distribution, which tells us how often a value appears. So what do we measure in frequency distribution? Okay, the frequency, or how often the data appears, right? So that's your frequency distribution. So what you do here, we have your count, all right, your occurrence, your data spread, yes, yeah, your data spread, and even your intervals or your categories. Okay, next, we also have your percentage, okay, which show proportions of a whole. So this one, proportion, proportion, ratio, part to whole. Now, usually we do percentage if respondents are only required to give one answer. But if they will have multiple answers, or if they are going to, let's say, select all that applies, or they could choose as many options as they can, percentage is not really applicable. Okay. Measure of central tendencies, of course, we know this already. We have your mean, which is your average, of course, your median, or your middle score, right? And your mode, or your frequency, or your most frequently occurring data. Okay. Now, let's not forget, if we have your measures of central tendency, it goes hand in hand with measures of variability, because what does your measures of variability really do? Okay, it actually measures homogeneity of your data. Meaning, we're talking about like how spread. Oh, right? So we're talking about how spread the data is. Sir, what's like the implication if we would say that the measures of variability would say that your data are homogeneous? So basically, class, if your data is homogeneous, which is usually indicated by a low SD and low range, it means that your data is actually consistent, reliable, and it really pictures, the performance of the group or the population because responses are not really very different or diverse. However, if your measures of variability is high, I mean your standard deviation or your range are actually kind of high, all right, then your data is heterogeneous. So meaning there is what? So there's high SD, high range, okay? So your data has a lot of what we call your outliers. Like it's not really a definitive picture of the sample or the population because of how diverse your data is. Okay. Now, um, descriptive statistics actually used because most of data collection method is done in survey, well, in psychology, okay, or in other social sciences. And one of the important, okay, or let's say one of the common type of closed-ended or structured uh, test or structured questionnaire that we do is your Likert scale. Okay, so let's talk about your Likert scale. So we are focusing on interpreting the mean of a 5-point Likert scale in this example, and it's often used in surveys to measure levels of agreement or disagreement with a statement. Now, if you've noticed, we have here, I just forgot to actually highlight on that one, but here we have, oh my God, it's very big, sorry. Oh, we have here your mean range. There, can you see it, guys, class? So that is the purpose of your mean range. It gives value to your mean or to your average score. Usually in a Likert scale, it's depending on how many or how many point there is. And so we get the average and then we place the average according, I mean, we interpret the average according to these ranges. So for example, if you get a very, very low mean, just like this one here, okay, and strongly disagree or like very low level, right? So yeah, that's the beauty about Likert scale. It's easy to use and it's also easy to interpret. Okay. Now let's go to inferential statistics. Now in inferential statistics, we estimate, okay, I want you guys to remember this. What do? We estimate. We also test and we predict. So the process is kind of um, rigorous or very complex because the purpose of how we analyze the data is also kind of complex because we estimate, test, and we predict. So this is where we can analyze relationships, compare groups, okay, and at the same time make predictions. So for instance, if we can test if a new teaching method works better than the old one, or if study habits impact grades, inferential stats help us go beyond describing data to making predictions and testing theories, which is a powerful step in research. And especially if for sample data, inferential statistics is very, very helpful. Okay. So What do we do in your inferential statistics? So first, we estimate population parameters. So what do we do here, class? Of course, we make inferences. Oh, sorry. We make inferences about population characteristics. Yes. So what does the population show based on the sample data? So that's estimating population parameters. So yeah, like for example, your confidence intervals and the like. Number two, we have your hypothesis testing. So you're trying to prove claims about population parameters. Okay. Prove your claim about population parameters. So that includes your t-test, your chi-square, okay, and your other tests as well. Yeah. Then we have analyzing relationships, of course, associations. Okay. So regression analysis. So here we will have our regression analysis, okay, and correlation also. Comparing groups, what do? We establish whether there is statistical difference. We always encounter statistical difference whenever we do research, but what does that really mean? So, for example, let's say two groups have very different mean scores. Okay. Let's say the group A has, for example, 16.4 and group B has 18.2. So at just first look, we can say that there is a difference because, the numbers are not the same. But if we really go deep into analyzing the data in terms of its how variable it is or how spread it is, you would really see that these two data are not actually statistically different. Okay. So that's the purpose of your comparison. So we have your ANOVA, your Mann-Whitney U-test, and one. And of course, we make predictions. So what do we do here? Yes, we forecast future outcomes. And how do we do that, sir? Oh, that's a good question. We base it from observed data. So depending on the quantity of data that we use as reference, we use those retrospective data to project future occurrences based on how the data actually behaved during the time that it was gathered. So yeah, we do inferential statistics if we want to estimate population parameters, test hypotheses, analyze relationships, compare statistical differences between groups, and making predictions. Okay, now here we go. This is just a quick note on a parametric versus non-parametric tests. In today's modern or contemporary research landscape, we are now very particular with parametric or non-parametric tests. That means it's no longer like okay, two tests, so therefore we just do t-tests, or there are multiple, we do ANOVA. It's not that easy, or it's not how it works now. So for a quick note, parametric tests are used when our data follows a normal distribution and meets criteria like a large sample size. So looking into the table, we'll be able to recognize that your, okay, parametric tests, I'll just highlight the parametric tests here. Okay, you have continuous. How would we know if we will apply a parametric test? If your data is continuous, large sample, and normally distributed. Okay. However, if your data is the opposite, so let's say there, if your data is discrete, okay, low sample size, and not normally distributed, then you do your non-parametric tests. Now, class, remember, among all these points to consider, the most crucial is, I want you to take note of this, the most crucial is a distribution. Why? Because regardless whether your data is continuous or if you have a large sample size, but when you check for the distribution of your data, it's not normally distributed, then automatically it will fall under your non-parametric tests. Okay? So, talking about parametric and non-parametric tests, to give you a further and better understanding of these differences between the two, how you analyze your data really depends on its nature and its attribute. Like, for example, it's kind of like obvious. If you have a small data, it's not very conclusive, right? So because it's not conclusive, having only a small data set, you cannot use an analysis that will lead us into a very conclusive result, given that your data is not that large. Okay. So that's actually the premise of your parametric and your non-parametric test. You use a certain test depending on the nature of your data. So, like on this table, okay, let's take a look. Your parametric tests are Pearson R. Okay. I'll put the green only for parametric. T-test for independent samples. All right, your t-test, your ANOVA, and your regression. Now the rest, your phi coefficient, your Spearman rho, McNemar, Wilcoxon, two-way chi-square, Mann-Whitney U-test are all non-parametric tests. So you would be able to see here which test is suitable for what kind of data, what category or the analysis, or the type of the purpose of why the test is going to be used, and whether it's parametric or non-parametric. So I want you to take reference of this. It's really very good, okay? All right. So, yeah, we'll try to discuss one by one. So let's begin first here. So this table actually provides an overview of tests that researchers can choose based on the nature of their variables and their specific research questions. So let's get into each category. So first, we have a test of relationship between two variables. Test of relationship between two variables used to determine association, all right? Remember this, it's always association class, okay? No, sorry. Okay, oh, sorry. It's association, right? Okay, between two variables. For continuous, we use Pearson R. You see there, okay? Continuous variable, Pearson R. And which is a parametric test, strength and direction of a linear relationship. We use your phi coefficient on the other hand if it's nominal or dichotomous. Dichotomous meaning only two, like yes or no, or let's say present or absent in a non-parametric approach. Spearman's rho, on the other hand, is a non-parametric test suitable for, take a look, ordinal variables and measures the rank order correlation. Now, if we wanted to test for difference between two data sets from only one group, meaning only one group produces two data sets, this category tests differences in measurements taken from the same group under different conditions. So for continuous data, we do your t-test. For dependent samples, as a parametric test comparing means, we do your McNemar for nominal or dichotomous data, or your Wilcoxon sign rank test if another non-parametric test used with ordinal data for compared two related samples. But if we wanted to test the difference between two data sets from two groups, so meaning here you only have one group, so let's say group one produces your pre-test score and your post-test score, So you're going to use either t-test, McNemar test, or Wilcoxon signed rank test for this analysis. But in here, if you, let's say you have group 1 and group 2, and then group 1 gives us a post-test score, and group 2 also gives us a post-test score, then we have two means coming from two different groups. So we use your t-test for independent samples. T-test for independent samples for continuous data, okay, which is a parametric option. Your two-way chi-square for a non-parametric test for nominal data. Here, your two-way chi-square, nominal data, okay, for association between two categorical variables. And for your ordinal data, we use your Mann-Whitney U-test. Ordinal data, actually class, this one is your Likert scale. So if you're using Likert scale and it is more on if it meets the non-parametric requirements, then Mann-Whitney is usually utilized. But if we have more than two groups, then ANOVA here, and of course your multiple regression. All right, yay. So class, I hope you were able to learn something from today's lesson, okay? And thank you for sticking with me all throughout this lecture on quantitative data collection and analysis. And remember, all right, remember, the methods and tools we talk about today are all about transforming real-world questions into meaningful numbers we can analyze. By using these techniques carefully, we can find answers, make predictions, and contribute valuable insights to the world. And of course, okay, valuable insight to the world, questions into meaningful numbers we can analyze. Keep exploring and asking questions, and well, Story Searcher is just here for your guidance along the way. So good luck and see you next time. Class dismissed.